Hello everyone, welcome to my YouTube channel. From this video onwards, we are going to develop a small series of video in which we are going to discuss about two different approaches to actually communicate between one microservice to another microservice. One is using the Feign client and another is using RestTemplate. And this is I'm going to demonstrate in the Spring Boot application. So before we dive into those particular stuff, first thing we have to understand what exactly is the cause to use those things, right? Like what is the exact cause that we have to learn to intercommunication between the microservices or the services. So let's quickly start with the architecture. To understand this, first we have to understand the monolithic architecture, then we will understand the microservice architecture, and then we will see the differences between these two and what exactly the cause to develop this intercommunication between the services. So let's quickly start with the monolithic architecture. So here in the screen, you can see that we have a different desktop applications with which we can actually access the services. So either you can use any one of these or you can use from the device also. Here we have a load balancer. Load balancer, what basically it does is, suppose I have a two service deployed. So this is the number one service and this is a monolithic architecture. And if I have two copies of the same architecture, let me just make a copy of it. Copy and let me quickly paste this. Suppose I have two different services. Okay. In this case, what will happen is the task of load balancer is to detect which service is having less load. On the basis of that, it will reroute the traffic. If this one is having less load, the traffic will go to this one. Now this one is occupied with so many loads and this one is free. In that case, the traffic will be rerouted to this particular service. So in this way, load balancer works. So if you want to understand the load balancer in detail, internally it works on the consistent hashing. So if you want me to make a separate video on that, then please comment in the comment section. I will make a separate video for it. So let me move back to this one. I hope you understand what exactly this one is. Okay. So now move back to the actual stuff which we are discussing. So when we talk about this one, that is the monolithic architecture. Monolithic architecture basically means that all the things whichever required in your application is in one place. So suppose I have one service in which I'm actually managing an inventory and selling that product to the customer. So in this case, I have one customer related APIs, that is, I will have customer CRUD. Okay. So we have create, update, create, read, update, and delete. All the operation, all the APIs we will have in our service, right? Again, we have order because customer is going to place an order. Again, we will create an order, read the orders, update the order details, and again, we can delete also. So these all operation we are going to perform, right? So in this case, all these APIs is residing in a single application, and that is called monolithic architecture. Everything chunked as a single application is called monolithic architecture. So what is the problem with this one is that suppose something goes wrong in the customer service, right? So in that case, the order will also be halted. It means that if something goes wrong with the customer development, in that case, this whole application will not work properly because everything packed as a single one and it's been deployed to the services, right? So this is the monolithic architecture. It means that everything is packed as one and deployed as a single unit. So this is also easy to develop as an initial phase, but with the time grows, it will grow as a very large chunk and it will cause. Next, we will see the microservice architecture, the alternative for this one. So here we have this microservice architecture. What exactly this is? We have different services, small chunks. So first service, can we say this? This first microservice I have developed is for /customers. All the APIs related to customer. I am just giving an example that I have only CRUD application, CRUD API, that is create, update, read, and delete. But in the actual scenarios in the services in the organization, we have a lot of APIs. So on the what basis you are going to divide the microservices, that is also a very critical thing which needs to be taken care by the architects. Okay. So here I'm just simplifying the task for the understanding purpose. So first what I did is all the customer APIs, I'm going to deploy as a separate microservice which has its own DB, not dependent on the another. Another microservice which I have is /orders, which again have its own DB. Okay. So in this case, what will happen is for this particular microservice, can we have its own language? Like suppose I want to develop this one in the Spring Boot, and if I want to develop this one orders in the Golang. So we have this flexibility, right? Because they are completely separate and it's working in isolation with their own database. So this is also possible. So main reason why it came into picture that we have to like intercommunication, because now these are deployed as a separate unit. Now what happen is, suppose a requirement where I want customer details, okay, with all his order. Okay, this is the case. I need customer details with all his orders, whatever the orders he has placed so far. In that case, what I will do is I will, from the UI side, I will give a request to the API gateway. API gateway will come to my customer microservice. Okay. It will reroute the traffic to the appropriate microservice. After that, what will happen is it will internally make a call to the order service, and it will fetch all the all the orders related to that particular customer and fetch it from the database, and it will return to this microservice, that is the customer one, and then it will return to the user. This is the scenario. So here exactly we get the use case of inter-microservice communication. And this is the reason why we are going to learn the two different ways of intercommunicating between the microservices or the services, right? So let's quickly remove these all. Okay. So this is the use case where we are going to see. Okay. Next thing what we have is, again, we have the two microservices. Let me just demonstrate it over here quickly. So first, this is a request coming from the user. Then it will fetch, this one is customer, this one is order. And we again have the database over here. So this will hit ask for all orders related to customer. This is particularly, actually it's going to hit one API, okay, / whatever the name, suppose some name, okay. Then it will process whatever the logic we have written at the service level. It will process and get it from the database, and it will revert back to this microservice. It will prepare one JSON with the customer detail and the order details. Okay. And finally, it will send it back to the user. So we are going to demonstrate these all stuff by using the two techniques. That is, one is the Feign client and another is the RestTemplate. Okay. So before we go and dive into the coding, first thing we have to see the differences between the microservice architecture and the monolithic architecture. For that, I have created one small table. Let me quickly show that to you. So here we have one small table. Okay. So in the monolithic architecture, on the basis of this architecture, it is divided, or this one is as a single unit and individual unit. As I mentioned that all the data related to suppose customer and all the other stuff will be deployed in a single place slash customer and everything, customer slash orders, and many more is deployed in a single unit. But in the microservice architecture, what happened is everything is decomposed into small units, as we have seen that, right? One pods. I'm just giving an example of one pods, but in the real life, we have a replica set, which basically that how many copies of that particular pods you want. Pods means one service is deployed form. Okay. So divided into smaller and independent service. Independent services means is that if that particular fails or something goes wrong with this service, then this one will keep on working. No impact on these two services, right? So, and we got the flexibility to develop this one in another language, this one in another language, and this one another language. In any language we can develop. Okay. Next thing, on the basis of scalability, scaling involves replication entire application. Okay. Replicating entire application. What it means is, suppose if I want to deploy only the customer APIs, because I have a lot of, like, there are so many hits I'm getting for the customer. Okay. Let me just demonstrate that with help of example. Suppose this one is a monolithic architecture. Okay. Monolithic means that everything is in the same place. So slash customer slash orders, everything is in the same place. Okay. So in this case, suppose I'm getting request and the users of the customer's APIs is 1000K. And for the orders API, I'm getting only 10K. Or you can revert it as per your choice. This is just for an example. So in this case, if I want to replicate or if I want to deploy more pods only for this customer, then is that be possible? No, right? We have to deploy the complete as one. So this will be deployed in this particular format. Let me quickly copy this. It will be replicated like this. But again, this one orders is not required, right? Because this one, whatever the requirement for this orders is already being fulfilled by here only, not required to deploy separately. This is, I'm talking about monolithic architecture. So that's complete deployed as a single one. Okay. So in this case, there will be a loss of memory, or we can say loss of resources, inefficient utilization of resources. Can we say that? Because as per this one is deployed, is orders API is being used? No, right? So in that case, this one is inefficient. If we talk about the scalability of microservice architecture, granular scalability, services can be scaled independently. What it means as, suppose I have one microservice and another microservice. This is for orders. This one is for customers. Again, for the orders, I'm getting 10K, and for customers, I'm getting 1000K. So in this case, I can deploy this one as separately. So I can have now two microservices of customers without deploying this orders. So in this way, we have granular control. It means that a small chunk of a service can be deployed separately. So this one is P1, this one is P2 for customer, and this one is P1 only. If the requirement of orders increase, in that case, we can increase the pod of this orders also. So we have a general control. Next thing what we have is, as per the deployment and development, simpler development and deployment process. So as this one is deploying, monolithic architecture is being deployed as a single unit, so it can easily be developed and easily be deployed. Okay. But in the case of microservice architecture, more sophisticated process, independent service deployment, it needs to be like, I have a different configurations for each of the microservices, right? So we have to deploy it separately from the each other. So we cannot use the same thing to deploy the another one, because the database connection name or password needs to be different. It may have the different databases as well. There are different configuration, like for one pod I need, for one service I need only one instance. For another service I need 10 instances. In that way, this one is also differentiated. If we talk about the technology diversification, so in this case, this one is being developed as a single one, right? So in that case, single technology stack. It means that if application is going to deploy or develop in the monolithic architecture, in that case, either it should be only in one language. Select once at the starting. Either it can be in a Spring Boot completely, or it can be in Golang or Node.js, whatever the language you will think of, it will be of only one. But if we talk about the microservice architecture, as everyone is independent, so first microservice can be of Spring Boot, second microservice can be of Golang, third microservice can be of Node.js. As per your requirement, you can diversify. Okay. If you talk about the fault isolation, in this case, failure can affect the entire system. So over here in the monolithic architecture, we have only one service, right? So if anything goes wrong in the customer, then it will impact the whole service. But over here, we have a separate microservices. So in this case, if anything goes wrong into this particular service, then this one will keep on working because this is independent. So it is always failure in one service doesn't affect the other. This is a clear statement. So what happens is, if the first pod or service goes down, then another will keep on working, right? Third thing is, in the complexity way, monolithic architecture can become complex and unwiderly. It means that as the application grows, initially you will see that this application is easy to develop, right? But with the time you will see, as per the requirement grows, it will get very complex and very hard to manage by any person or any team, right? You won't be able to modify things faster. Okay. Another thing, if we compare about the microservice architecture, offers better modularity, but managing distributed system introduce complexity. So as a single small unit, if I talk about this one, small unit 1, we have 2, we have 3. So if we want to like manage the individual one, is very easy, right? Because we understand things that this one is developed for this particular reason, and whatever the things, it can be easily organized and easily managed because all are divided into small chunks. But only complexity increases between the intercommunication. Okay, that is the one challenge. Everything whatever comes in the market is with some of the benefits, and it also have some cons. Pros and cons are always there. Okay. Team organization, close coordination amongst the team, as there is a single application. So the coordination will be close. If you talk about the microservice architecture, allows for more independent team, faster development cycles. Because I have 10 person over here, 5% over here. So these 10% can independently work on the first microservice without being worried about the another microservices and another things which needs to be managed. Because the another team is also managing the same stuff, the separate segregated service, right? So in this way, independent team is working on the independent services, set of services. So it is faster it can be developed, right? Because the completely focused mindset is working on that particular set, right? So these are the main differences between monolithic architecture and microservice architecture. If you like this video, then please give us a thumbs up and subscribe to my channel. In the next video, we are going to basically develop 2 microservices. One is customer and one is order. And after this one is the first video. After this one, okay, if I consider this one as first video, then second video, we are going to develop this 2 MS1 and MS2. Okay. In the third video, I'm going to show you how to do the intercommunication between these 2 microservices using Feign client. In the fourth video, I'm going to show the same by using RestTemplate. So as an IT expert, you need to know all of these things. Okay, so I hope you like the content. Please like and share. Thanks for watching.